Okay, for this video, I'll be going through pure physics, chapter 7, kinetic model of metal, success criteria D. Okay, success criteria D states that you need to be able to relate the rise in temperature of a body to the increase in average Ke of all the particles. That means from this we can see that as temperature increases, the Ke of all the particles in the body will increase. Okay, so what is temperature? Is the temperature reading of a substance is an indication of the Ke of the particles of the substance. Okay, Ke rises with the average Ke. Temperature rises, with the average Ke of the particles in a body and vice versa. That means if temperature were to decrease, the Ke will decrease. Okay, or if the particles Ke decreases, that means the temperature of the body will also decrease as well. Okay, now take note that the average implies that the temperature is applicable only to a collection of particles and not to a single particle. Okay, so we take the Ke of all the particles, we sum it up, and then we take an average, okay, and that will be the temperature. Okay, so measuring temperature of a substance, example of hot water using a thermometer. So when a substance such as water is heated, the energy in the kinetic store of the particles increases and the particles vibrate or move faster. Hence, when a thermometer which is in contact with the water, the more energetic particles in the water will transfer some of the energy to the less energetic particles in the thermometer through collisions. Okay, so you'll learn this in the transfer of thermal energy, more details. Now, with more energy, the particles tend to push each other further apart, so the metal expands. However, liquid expands more easily than solid, so the liquid column in the thermometer expands noticeably along the calibrated scale, but the length of the thermometer's glass body hardly changes. Okay, so an important point to take note here is that the particles will push each other further apart. Okay, and that leads to the expansion. Now, when the temperature in the air is increased, the average speed of the air molecules increases, right? Because thermal energy is transferred to Ke of the air molecules. And the force and frequency, important, of collision between the air molecules and the suspended particles will increase. Therefore, suspended particles will move faster and change direction more frequently. We have covered this under Brownian motion. Okay, so we are unable to actually see the air molecules because they are invisible. However, if we have some particles that are suspended which are visible, like your smoke particles, right? Okay, the smoke particles will move faster and change direction more frequently due to the force and frequency of collision between the air molecules and these suspended particles. Okay, so let's try question D1. A rigid container is actually filled with nitrogen gas, which we can't see. Okay, some smoke particles which are visible are introduced into the container. Describe the motion of the smoke particles in a container when the container is placed in a freezer. So what happens when it is placed in a freezer? The temperature surrounding the nitrogen gas, okay, will decrease, and therefore this will lead to the nitrogen gas particle, their Ke will decrease. Okay, so the speed of the the nitrogen gas particles will decrease as well, because as Ke decreases, speed decreases. So this leads to the force and frequency of collision with the smoke particles to decrease. Okay, and therefore the smoke particles will move slower. They will move slower and change direction less frequently. Okay, so the concept here is you must link temperature to the change in temperature to the change in Ke. Okay, Okay, question D2, when a solid is heated, okay, the state is solid, it will change to a liquid and eventually a gas. In which state are the particles the biggest? Answer is D, the particles remain the same size. So when something expand, like solid expand, liquid expand, or gas expand, it is the spaces between the particles that increase. Okay, in example, if I were to heat up a gas, right, the particles will move faster because their KE increases, right, and they tend to push each other further apart upon collision. So the spaces between the particles actually increase and not the particle size increasing. Okay, success criteria E, explain the pressure of a gas P in terms of the motion of its molecules, which is the gas molecules. Okay, so we are now able to explain, link this to the pressure. Now, you know that the gas molecules are constantly moving in random direction and they will collide with the inner walls of the container. Now, when there are many gas particles colliding with the inner walls, the forces add up. They exert a force upon collision. The total force exerted by the gas per unit area is the pressure. Okay? At the particle level, pressure is the average force exerted by the particles per unit area. So gas pressure in the container is nearly the same throughout the container because there are so many particles. Yeah. So the pressure of a gas in a container is the same at all points in a container. Which statement explains this? So this is our E1. Okay, is it because the gas particles are moving in continuous and random motion? This is a true statement, but it doesn't explain what this sentence means. Okay, the gas particles have the same size. That is true. The gas particles make the same number of collision with the internal walls of the container per unit time. I think the answer is actually D. Okay, so this is true as well. They make the same number of collision with the internal walls of the container per unit time. Make the same number. Oh no, this may not be so true. Okay, they make the same number of collision with the internal walls. Okay, they will not make the same number because they are existing in random. They are moving in random direction and with different amount of KE, different amount of speed. Okay, so this is a better answer. The gas particles actually move at the same average speed. Okay, so if they move at the same average speed, right, then they will have a net force that they exert, which then accounts for the pressure, as pressure equals to force over area. Okay, let's go to E2. A cylinder with a piston contains a fixed mass of gas at a constant temperature. So whenever there's constant temperature, then that means there is no change to kinetic energy. Okay, the piston compresses the gas without a change in temperature. So again, they highlight this, that there's no change in temperature. Okay, what happens to the pressure of the gas and the kinetic store of the gas particles? Okay, so the pressure of the gas, now that you have actually a smaller, because it compresses the gas, right? It's a piston. Okay, it's a piston. So actually, as this thing goes down, the volume actually decreases. So we have a number of particles. This is an important phrase. Per unit volume to be increasing, right? Because initially I have this number of particles inside, and now I'm pushing the syringe down, the piston down, so that the volume decreases. So now all the particles are closer together. So can I say that the number of particles per unit volume increase? Yes, right? And what will happen to this? The frequency of collision will increase. Okay, so imagine I'm staying in a 3-room flat. I have a few family members staying with me, and suddenly all of us are restricted to one room, staying in a room. So the frequency of us colliding with one another or having argument will actually increase compared to if I were to now upgrade to a bungalow with 10 rooms. All right, then different members stay in different parts of the house, which we won't come into interaction with each other. So the frequency of collision will then decrease. Okay, so if the frequency of collision decreases, then since pressure equals to force over area, the average force that the particles exert on the inner wall will increase because the frequency of collision increase, right? So the pressure will actually increase. The kinetic store of the gas particles will stay the same because they keep telling us that there's no change in temperature. Okay, so answer is D. Okay, E3, a car tire contains a constant volume of air. So now the volume is kept constant. When the car is in motion, the air in the tire becomes warmer and the air pressure inside increases. So the pressure increases from the statement. The air also becomes warmer, so the temperature increases. So which of the following about the air particles in the tire when the car starts to move is correct? So the number of air particles in the tire actually remains unchanged, right? Because that is the limited number that they are trapped inside the tire. Now the force exerted on the inner walls by the air particles will actually increase. Okay, because pressure equals to force over area. So the force actually increases, right? Because pressure increases. The number of collisions per second between the air particles and inner walls, what did they say? They have a constant volume. So because the volume is constant, right? And therefore, the number of collision between the particles will actually increase. Why do they increase even though the volume remains constant? Because as temperature increase, the Ke also increase. When the Ke increases, there's a higher chance of collision. The frequency of collision increases. And also the force of collision will increase. Okay, so maybe we can sum up the two effects. The first one is when volume increases. Okay, so what happens when the volume increases? The number of particles per unit volume actually decreases. Okay, if I'm talking about a fixed mass of gas, fixed number of particles, because as the volume increases, we have more space, the number of particles per unit volume decreases, and that will lead to a decrease in frequency of collision. Okay, but what about the force of collision? That the particles collide with the inner wall, it will remain the same because now I'm only changing the volume. Okay, so this is one effect. The other effect that we can change the pressure, okay, in the container is by changing the temperature. So let's make temperature increase. When temperature increases, Ke of the particles will increase. The speed of the particles will also increase. So now that we have particles that are moving faster, there will be two effects. The first one is the frequency of collision. Okay, because they are moving so much faster, there is a higher chance of them colliding with one another. So the frequency of collision will increase. The other effect is the force of collision will also increase, right? Because now they are moving faster, definitely the force that they collide with the inner wall will also increase. So temperature actually has two effects: frequency of collision increasing and force of collision increasing. Whereas if you only were to change the volume, there is only one effect. Okay, so you need to know this term, the number of particles per unit volume. Okay, if volume increase, then the number of particles per unit volume will decrease, and that will lead to a decrease in the frequency of collision. So you can use this to answer the question depending on which scenario that they give.